Hello everyone, my name is Sigdel from Western Sydney University, Sydney, Australia. Today I'm going to present about the integral bridge abutment soil interaction analysis using PIB technique. First of all, integral bridge abutment, also called as jointless bridges. In the integral bridge abutment, there are no expansion joint in the superstructure between spans and between spans and abutment. Because of this structural configuration, integral abutment bridges are less expensive to construct and easier to maintain in comparison with the traditional bridges with expansion joints. According to a survey on integral abutment bridges conducted by the University of Maryland in 2009, 41 states in USA are using integral abutment bridges. Not only in USA, it is recently very popular in European countries and also in Asian countries and also in Australia. Though it does have many advantages over the traditional type of bridges, it also has some inherent geotechnical issue. Because of the daily and seasonal temperature changes, the abutment will move inward and outward due to the expansion and contraction of the bridge deck. Because of that, the complex soil structure interaction mechanism will happen in between the retained soil and the bridge abutment. As a consequence, the lateral earth pressure behind the abutment will start to build up. Because soil is inherently nonlinear and inelastic in behavior, so after the number of cycles, the soil properties will start to change and they won't regain their original properties. Also, because of cyclic moment transmitted to pile foundation, it can induce greater bending moment in the integral abutment. Also, because of the active and passive movement of the abutment towards and away from the soil, by the time it will cause the soil settlement and soil heap behind the abutment. As a consequence, the lateral earth pressure will start to build up behind the abutment, which is also called soil ratcheting effect. So, in order to understand this complex soil structure interaction mechanism, I have done two tests using the small scale tank with the help of the PIB technique. So as you can see in the figure, the small tank consists of the steel wall, which can move inward and outward from the retained soil. And the front side of the tank is transparent to capture the image during the experiment. And the supporting bars are to move the steel wall towards and away from the soil. The PIB technique, which is also called particle image velocitometer technique. Here I have used GeoPIB using the MATLAB. So from the number of images from the experiment, the PIB will analyze the images and then it will give you the soil deformation due to the certain mode and magnitude of the wall movement. So is the flow chart of the experimental procedure, and the right hand side, the image obtained from the 20 mm of active translation moment and from the 20 mm of passive translation moment. The first figure on the top is due to the 20 mm of active translation moment, and the second one is from the 20 mm of passive translation moment. As you can see in the figure, the magnitude of the total displacement is higher during the active translation moment. However, the area of soil deformation is higher during the 20 mm of passive translation moment. So also you can see waste shape of failure during the passive translation moment. Also, the total shear restraint plot and the total volumetric restraint plot after 20 mm of active translation moment is on the left-hand side, and the total shear strain plot and the total volumetric strain after 20 mm of passive translation moment on the right-hand side. You can see the clear shear band formation in the both experiment, and the area of soil deformation is higher during the passive translation moment. However, the value of soil rearrangement, soil deformation is higher during the active translation moment. From these two experiments, it concludes that the significant amount of soil deformation is happening behind the abutment due to the abutment moment. It also implies the complex soil densification and loosening is happening in different parts of the approach field and at different stages of the abutment moment. Also, the formation of settlement trough and the heap suggests need for design modification to mitigate this issue. And continuous soil densification behind the abutment wall during monotonic passive and active moment supports the soil ratcheting effect. Also, soil deformation due to the abutment moment implies that the soil properties change continuously during the wall moment, and it's also cyclical in nature. And also from the shear strength plot, it shows that the soil deformation was concentrated inside the shear band. Thank you very much.